Welcome to Gottman's UG. In this video, I'm going to be dealing with Coulomb's law of electrostatics. So, this is a law that states that the force between 2-point charges, for example, if I have 2-point charges, I'm having, for example, at this point, and at this point, I'm having Q1, and at this point, I have Q2. And they're separated by a distance d. So you find that by Coulomb's law says that the force between 2-point charges is directly proportional. So let's say the force is directly proportional to the product of the magnitude of the charges. So I have Q1 and charge 2, and inversely proportional to the square of the distance of separation of these charges. For example, I'm having here. So Coulomb's law itself states that the force between 2-point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance of separation of these two charges. So you find out of that, this would be force, which would be equals to K. This would be charge 1, charge 2, all over d squared. And in this case, you find that force would be equals to, if we are to identify this K, of which K would be equals to, this would be 1 all over, this would be 4 pi epsilon naught, yes? And therefore, I would say that this would be charge 1, charge 2, all over. Here I would have 4 pi epsilon naught d squared. So out of that, you find that by this, but you find that in this case, epsilon naught would be equals to, I would have 8.85 times 10 to the power negative 12 farad per meter. And this is what, let's say, permittivity in air. Here is what we use. Now, having known that K, for example, our K was equals to 1 all over 4 pi epsilon naught, of which this, if you insert this into your calculator, you get 9 times 10 to the power 9. And therefore, you find out of that, we would say that our force would be equals to 9 times 10 to the power 9. Let's say charge 1, charge 2, all over distance of separation squared. So you find out of that, this is the main expression that we are going to use here. And this is what I'm going to use to mostly solve most of the problems. Consider a problem of this kind, that find the force between 2-point charges. We have this a positive new Coulomb and negative 3 new Coulomb plus 10 centimeters apart. So you find that to calculate for such a problem, you first locate these charges, and therefore say that I'm having here, for example, at this point, I'm going to have, let this one be negative 3 new Coulombs. Then I'm going to have here, let this one be, I'm going to have positive 4 new Coulombs. So the distance of separation of these two charges is 10 centimeters. 10 centimeters. So having known, but if I look at this, they want us to determine the force between these 2-point charges. And therefore, from Coulomb's law, we know that the distance of separation, our d, is equals to 10 centimeters. Yes, and we have this like charge 1 equals to positive 4 new Coulombs. Then, and our Q2, which would be equals to negative 3 new Coulombs. And therefore, I'm going to come here and say that the force between these 2-point charges would be equals to, I'm going to have here, which would be 9 times 10 to the power 9 Q1, Q2, or charge 1, charge 2, over the distance of separation, but squared. And therefore, I'm going to have 9 times 10 to the power 9 times, I'm going to have, this is going to be 4 times 10 to the power negative 6 times, I'm going to have 3 times 10 to the power negative 6 all over the distance of separation, which would be, you convert this to meters, and therefore I'm going to have something which would be, in this case, this would be 0.1, but this would be squared, and therefore the force between these two, if I insert this into my calculator, therefore here I'm going to have, which would be 10.8 newtons. But since this is a force, and force is a vector quantity, and therefore it has magnitude and direction. So in this case, I'm going to say, if you look at these forces, so you find that the force between the positive new Coulomb charge and the negative 3 new Coulomb charge, the force between these two charges is attraction, and therefore I would say attraction. But towards which direction? Who is going to attract who? Are you saying that? So you find that the positive 4 new Coulomb charge is greater than the negative 3 new Coulomb charge, and therefore the attraction would take place towards the left. Attraction towards the left. So you find that you have to give the direction of the action of the force in this case. Now, consider such a problem that 3-point charges are placed at point A, B, C as shown below. And therefore, from A to B, the distance of separation is 10 centimeters. Then from B to C is 5 centimeters. They are having negative 3 new Coulomb charge, positive 4 new Coulomb charge, and negative 7 new Coulomb charge. Now, they want the resultant at B due to these charges. Yes, due to these charges. And therefore, if you look here, now negative 3 new Coulomb charge and positive new Coulomb charge, the force that would be between these would be caused due to they will be attracting each other, and therefore the attraction in this case, because we consider the charge which other charges are acting upon to be stationary, of which it will be like a reference point in this case, and therefore the attraction in this case would be towards the left, and therefore we put the sign towards the left. Now, if this is force 1, yes, and here, now let's first get to in which direction is the force between positive 4 new Coulomb charge and negative 7 new Coulomb charge moving towards. You find that the force between positive 4 new Coulomb charge and negative 7 new Coulomb charge would be attraction, but this attraction would be towards the right hand side, and therefore this would be force 2. So let's get these forces. You find that force 1 would be equals to, I would have 9 times 10 to the power 9 times 3 times 4 times 10 to the power negative 12 all over the distance of separation of negative 3 new Coulomb charge and positive 4 new Coulomb charge be 0.1, but this would be squared, and therefore the force between this negative 3 new Coulomb charge and the positive 4 new Coulomb charge would be equals to, I'm going to have 10.8 newtons. That's like attractive, attractive, but towards left. So for this case, this one is done. Let's get the force 2. So force 2 would be equals to 9 times 10 to the power 9 times, I'm going to have 4 times 7 times 10 to the power negative 12 all over the distance of separation of the force at B and C would be equal, less like the distance of separation is 0.05, but remember this has to be squared, and therefore my force 2 would be 100.8 Newton, but also the force is attractive, and therefore attractive towards and therefore towards right. Now, having got this, for example, -7 new Coulomb charge and -3 new Coulomb charge are acting on the +4 new Coulomb charge, and therefore the resultant force between these two forces that are caused by the -7 new Coulomb charge and -3 new Coulomb charge would be got by, I have to get the difference between the forces, and therefore I'm going to come here and say that force that would be resultant force, that would be the resultant force, would be equals to, I'm having, for example, I take the greater one, which 100.8 newtons, because this one is towards the right, or I consider this like if they are in a Cartesian plane, that if this is taking the right direction, yes, that I draw, let's say, the axis here, that I'm having, let's say I'm having the y, and this one to be x, and this one to be y. You find that in this case, I would have something that would be that this one is moving towards the positive x, and this is moving towards the negative x. And therefore, in that case, I would say that instead of having this, I would come here and say that I'm going to have this one that's moving towards the right. I would say that 100, because so it would be positive 100.8 newtons plus. Now this is moving towards the negative x, and therefore plus negative 10.8 newtons, and therefore I would have here that this would be 90 Newton towards the right, and therefore this would be the resultant at B. This would be the resultant at B. So you find that after I can consider that, let me get the difference between these two, then the greater force, and therefore the greater force is the one that gives me the direction, of which in this case this would be the greater force, and therefore this greater force, after subtracting the 10.8, would give me the direction towards the right. Or I can consider, let's say, the Cartesian plane, that if I'm having y and I'm having x, but you find that the force 2 is moving towards the positive x, and force 1 is moving towards the negative x, and therefore I work out according to the Cartesian planes, and therefore having x and the y axis. Then I consider the direction of these forces. Then afterwards, after resolving, you find that I still come out with the correct answer. So that's it for this problem. Now for this example, I've been told to find the force on -3 new Coulomb charge, and therefore I first look at direction of action of these forces. So this is the -3. This is the -3 new Coulomb charge, but you find this I'm having, for example, at point B, I'm having this -3 new Coulomb charge, and therefore the force between -3 and 2 is attraction, and therefore this one is stationary, so this one is acting on this, and therefore it would be attraction in this direction, of which this would be force 1. So if I look at -3 and -4, and therefore the force between these two charges would be a repulsive force, and therefore this -4 would repel this in this direction, and therefore this would be our force 2. And therefore let's do the calculation. So force 1 will be equals to 9 times 10 power 9 times the first charge, which would be 2, times I'm going to have 3 times 10 to power negative 12 all over the distance of separation, which would be 0.02, and this would be squared. So this would be equals to 135 newtons, the same. And the force between this one and this is attractive, but the direction would be, this would be to the left, to the left. And therefore let's say we have got the direction and the force. Now let's get F2, and therefore F2 would be equals to, I'm having 9 times 10 to power 9 times the force 1, which would be 3, times the force 2, which is 4, yes, times 10 to power negative 12 all over the distance of separation, which would be 0.04, but this would be squared, and therefore this would be equals to 67.5 newtons, but this would be repulsive. In which direction? And then this would be also to the left, to the left. And therefore I came here and then I say that I'm having, if they are both repulsive, so they are both moving in one direction, and therefore here, let's like the way I would work out, I'll say that force that would be the resultant would be equals to, I'm going to have, this would be, I would have both are moving to the left, and therefore this would be 135. They are both moving in one direction, so you find that I'm having negative 135 minus, I'm having 67.5, but both of them are in newtons. So I would have something that would be 1202.5, but negative, yes. So but since here we take magnitudes, and therefore the force here that would be the resultant would be equals to 202.5 newton towards, you give the direction, and the direction would be, in this case I would have left, or you could say eastwards. So you find that I'm taking the magnitude, they are both going to the same direction, which is to the negative x, and therefore you find that both the forces add up to give the resultant, of which the resultant would be 202.5 newtons to the left. This example, I'm going to try to apply what we have used so far to work out this kind of problem. So for this case, they're saying calculate the resultant on the positive 3 new Coulomb charge, and therefore I'm going to come here and say that I'm going to first indicate the forces, that the force between the positive 5, remember we are getting the resultant on the positive 3 new Coulomb charge, and therefore the force between 5 and positive, this is also positive and this is positive, and therefore the force that exists between these, the repulsive force will take this direction, and therefore let's take this to be force 1, and therefore, and then the force between, it's like positive 8 and positive 3 will also be repulsive, but in the upward direction, and let this one be F2. Now the force between the negative 4 and the positive 3 will be attractive, but the attractiveness will go downwards, and therefore let's have an imaginary diagonal here, which would be in this form, but the force of attraction will move in this direction, and let this one be F3. And therefore let's work out and calculate for this. You find that f1 will be equals to 9 times 10 to the power 9 times, we're getting f1 times 5 times 3 times 10 to the power negative 12 all over the distance of separation. This distance is the same as the other one, so this would be 0.04 and this would be squared. So out of that, I calculate this by putting this into my calculator. Then I would have here, this would be equals to, I would have 84 point, I'm having 375 Newton. That's like Newton is to less like here we're seeing that it is taking this like to the positive x, and therefore this would be repulsive. Repulsive. That's like towards this, like let's put here in bracket, let this one be to the right. And then after that, let's work out for this. Let's say for force 2. So force 2, which force 2 will be equals to 9 times 10 to the power 9 times the charge 1. I mean the force 2 will be between 8 and 3 times 10 to the power negative 12 all over the distance of separation, which is 0.04 squared. And then this would be equals to, I would have 135 Newton, but this force would be upwards. So you have to be given the direction, but this force is a repulsive. Repulsive. So repulsive, but upwards. And therefore let's have force 3, or which force 3 because to force 3 is just like between 4 and that, and therefore it should be the distance of separation. We don't know that, so we have to calculate it. So from Pythagoras theorem, we know that this is 4 squared plus 4 squared would be equals to x squared, of which the x would be here. And therefore I'll have 16 plus 16, which would be equals to x squared. And then this would be 32, which would be equals to x squared. Then rooting this and rooting that. Therefore we are going to take here, this would be 5.659. This would be in centimeters. So out of that, to do this calculation, I would say that the force, which would be the third force, of course, this would be 3, would be equals to, I'm having 9 times 10 power 9 times, I'm having 4 times 3 times 10 to the power negative 12 all over the distance of separation, which would be 0.056569, but this would be squared. And then f3, which would be equals to 3.749 Newton. And then out of that, let's like, now it is lying in both y and x axis, and therefore the angle, let's say you have to get the angle, and therefore this angle here, you have to get this angle here, which is theta. So you find that to get that angle, I'm going to come here and say that, remember, that's like if I'm having both the opposite and the adjacent, and therefore what I would use there, I would say that tan or theta would be equals to, I'm going to have 4 centimeters all over 4 centimeters, and therefore here I would have, let's say, tan theta equaling to 1, which would be theta equaling to tan inverse of 1, which would give me 45 degrees. And therefore, having known that the angle between this the direction of the force and let's say like the x-axis is 45, now let's calculate the resultant in this case. By the force between this the 4 and the positive 3 is attractive, therefore we put the attractive. Having known that it is attractive, now let's work out the resultant. You find that the resultant in this case, resultant force, resultant would be equals to, I'm going to have now with respective direction, it's like on the planes. So you find out of that, I'm going to come here and say that I was having 84.375 repulsive, but this was between 5 and 3, and therefore it is moving towards the direction of the positive x, the positive x, and therefore I'm going to have 84.375, 84.375, but it is moving to the positive x, and therefore it is positive. But then in the y direction, we don't have a force acting in that direction, so plus another force in this case, which would be, let's go to force 2, of which force 2 is 135 but repulsive and upwards, so it is moving in the positive y direction, the positive y direction, of which y in this direction, y is positive, and therefore we are going to have y that is positive. Therefore x in this case is 0, so 135, of which this one is positive. Then plus, now let's go to force 3. Now force 3, we are having 33.749, 33.4749. So out of that, let's like, if we are to consider this like direction of this force, the force is attractive but downwards. So downwards, you find that if I obtain the cos of 45, yes, the force which is 33.749, so it will be moving in the negative x direction. So you find that the force in this case, this would be negative 33.749 cos of 45. Yes, because if I obtain the cos of this after, let's like let me extend this, that this is like this, so, and this moves like this, so this cos to this plane, the x, so this is negative, and therefore I obtain a negative cos of that, so that's why I'm having a negative here. So, and the sign in this direction, the sign, so you find that also the sign in this direction would be negative, because the sign of this angle here, if this is 45, so the sign would be also negative because it takes the negative y, negative y axis. So out of that, I'm also having negative 33.749 sine of 45. So now I work out the resultant from here. So you find that the resultant will be equals to x, I'm going to have 60.519, and for y I'm going to have 113.59, and therefore I obtain the resultant from here, of which the resultant would be equals to, I'll have the root of this would be 60.519 and this would be squared plus, I'd have 111.11359, and then this also would be squared. So out of that, I would get something that would be root of 116.013.7373776, and therefore the root of that should be equals to 126.5453975 Newton. And therefore, remember here you have to obtain the direction of this force. So out of that, you come here and say that to get the direction, you consider the direction of action of the forces, and therefore you resolve them to get the resultant. So in this case, you come here and say, initially we had, let's like, they were both moving to the positive. So you find that to get the resultant, we had, let's like, the forces. For example, after getting the resultant of the forces, which is like this, the resultant force that's acting at point, let's like, of the positive 3 new Coulomb charge. So out of that, let's like, to get the direction, I come here, I consider, let's like, the direction of motion based on this. So you find that I'm having, let's like, both are moving to the positive. That means that I'm having one in the y-axis and one at x-axis. So you find that I'm having here, I'm having on the y and x, I'm having on the y, I'm having 111.1359 Newton, and then I'm having here, I'm having 60.519 Newton. So after getting that, I know that it's like, now to get the resultant, I get the resultant from here, and so that the resultant will appear here, and therefore it will appear in this direction, and therefore my theta will be that. Okay, then after that, I say that to get the angle, I say that tan theta would be equals to the y, which is 111.1359 divided by 60.519, of which tan theta in this case would be, I'm going to have 1.8364, of which theta be equals to 1.4 degrees, and therefore the direction of this resultant force would be 61.4 degrees. It's like along, you say, along the x-axis, and then this would be the direction of that force. So you find that this is how you work out such a number. It's like such a problem, and therefore you find that, let's like, you work it out, but you have to be careful about the signs and how to apply them. So you find at the end of the day, you come up with the correct answer. And for these ones that charges are placed at an angle, you just know that after working out, you have to always resolve at a certain point. So this is it for this problem, and actually this is my resultant force, and the direction, looks like this is along the x-axis, and therefore this is how you work out this problem. Okay, in this example, we are going to be applying the same skills, of which here I've already indicated forces, of which this like the force between this and this will be repulsive, and the force between this and this will be attractive, but the greater force will be of the positive, let's like be caused by this positive 4 new Coulomb charge, because it will be attracting the negative 3 new Coulomb charge downwards, and you're having, let's say, the negative new Coulomb charge repelling the negative 3 new Coulomb charge upwards. So you find out of that the distance of separation of the charges has been given, and therefore here I'm going to come here and say that I have to get the angle A and angle B, but remember this is equals to that, only that there's a difference. Of course, I'm going to say that I'm going to have, if I want to get the angle A, that means that this is going to be 20 squared, which would be equals to 20 squared plus, I'm going to have, it's like C, which would be 10 squared minus 2 times 20 times 10, which would be cos of A. And therefore I'm going to have 400, which would be equals to 400 plus 100 minus, this is going to be, this is 200, and then this is going to be 400 cos of A, and therefore this is going to be 400, this is negative 100, which would be equals to negative 400 cos of A, and therefore 100 divided by 400, which would be equals to cos of A, of which cos of A would be equals to 1 all over 4. So having got that, therefore that means that A in this case would be equals to, if I have cos inverse of A, I'm going to get 75.5 degrees. So this is the angle between, let's like let's say this is the size of A, and at the same time it's the size of B, because if I have 20, that means that both sides are equal, therefore they possess equal angles. So after getting that, I come here and say that let me get force 1, of which force 1 would be equals to 9 times 10 to the power negative, I mean 9 times charge 1, of which I'm having 5, times, let's say like I'm going to have 3, then times 10 to the power negative 12 all over the distance of separation, which would be 0.2, but this would be squared, and therefore the force 1 would be equals to 3.375 Newton. Then this would be force 1. Then afterwards we have to also get force 2, and therefore force 2 would be equals to, I'm going to get, but this force here is repulsive, remember that, repulsive. You're going to give the direction afterwards. So you find that I'm having here force 2, which would be 4 times 3 times 9 times 10 to the power 9 times 10 to the power negative 12 all over the distance of separation, which is 0.2, but squared, and therefore here what I'm going to get, this is going to be 0.77 newtons, but this is attractive. Attractive. Okay, having got that, then afterwards I come here to get a resultant. So this one has components, of which in the y and the x, and this as well has components, of which when we are solving the resultant, that's we show, let's say like these components. So the resultant in this case would be equals to, I'm going to have something that if I'm having, so let's look at force 1. So force 1 is moving in the upward direction, of which if we are to get its course, it will be moving in the positive x direction, and therefore this would be 3.375 cos of our angle, of which we got here around 75 75.5 degrees. Now let's get for this like the y direction. You find that if we get the y component from here, you find that it will be moving in the positive y axis. So therefore, let's say I take the positive y axis, and therefore you find that here I'm going to have, this is going to be 3.375 sine of 75.5. So plus, these are in degrees and this one also in degrees, then plus I'm going to have this one also. Now let's look at 2.7. If you look at 2.7, it is moving downwards, moving downwards from here. Yes, downwards. And therefore, if I'm to resolve this, that's like for, let's say, to get the cos of it, you find that it will be moving in the positive x, and therefore cos in this case would be positive, because this is like, this would be b, so cos of b would be positive, and therefore I would have here would be 2.7 cos 2.7 cos of 75.5. But if I get less like the one that is moving along the y axis, you find that it would be negative, because to be moving towards the negative side of y, and therefore it would be moving downwards like this. Yes, and therefore it would be moving to the negative, and therefore I would have negative 2.7 sine 75.5, and therefore I get the resultant and say this is equals to, here I would get this like on the x-axis I would get 1.52521 and that's like the y direction, so this would be 0.6535, of which from here I can get my resultant, of which this would be equals to, I'll have a root here, that this would be 1.5211 squared plus this would be 0.6535, and this would be squared. Therefore this would be equals to the root of 2.7408, of which this would be equals to 0.6555 Newton. So you find out of that we have to determine the direction of this by resolving. So you find that I had both positives, of which I had 1.5211, then 0.6535. So out of that I use this, and therefore that means that in the y direction I had this, and in the x direction I had this, and therefore on resolving you find out of that I ended up with this. So after working out, you find that I have to resolve these vectors to show that the direction of the resultant was moving in this direction. So if I'm out of that, I do this. I come here and say that if I'm having, for example, in the y direction and the x direction, I was having, for example, 0.6535 Newton, and then here I was having that moving downwards to the x, 1.5211 Newtons. So after getting that, so the resultant will appear around here. So out of that, let's say to get the angle, I'll say that tan of theta, of which the angle in between this and this, so this would be equals to, I would have here in the y direction 0.6555 0.35 divided by 1.5211 and close this. So out of that, tan theta would be equals to 0.4296 2, of which tan theta in this case would be equals to tan inverse of this, and what I would get is like would be 23.249 degrees, of which theta would be approximately half here. This would be 23.2 degrees to the x-axis, and therefore this would be my direction for this force, and the resultant, which was obtained, 1.6555 Newton. So if it's like everything looks to must have worked out. So this is how we work out such a problem. Go step by step until you reach the final step. So if out of that, this marks the end of this, and thank you for watching. Don't forget to subscribe and turn on the notification. It's like and give the thumbs up if you like this video, and if you've gained something, hope you just keep the spirit, and always thank you.